Okay, when we ended in 4.8, we were talking about slope, and now we are going to start talking about slope as a rate of change. So when we compare two qualities that are changing, that is called our rate of change. And as the value of one quality changes, the other quality is also going to change. And how fast that happens is our rate of change, or our slope. You can find the rate of change using the slope formula as rise over run. So if we look at our first example here, you see that as you get older, as your age goes up from 8 to 12, your height also increases. And we want to know how many inches per year did this person grow. So to do that, we are going to pick our 2 points. So if we just pick the first and the last point here, and we have our x as our age and our y as our height. We are going to use our formula. So we have our slope equals y2 minus y1 over x2 minus x1. So we have y2, y1, x1, x2. We can plug those in and figure out our slope, or the rate of change, how much your height changed with age. So we would get 59 minus 51 over 12 minus 8, and that gives us 8 over 4, which is 2. So that means we would have a rate of change of 2 inches per year. So that's one example of how we find rate of change. We could do that with temperature too. So say over time, temperature of something is getting warmer. We want to figure out what is that average rate of change. Again, we're going to pick our first point and our second point. Our x is always going to be time, and our y is our other variable, our temperature. So we have x1, x2, y1, y2. Again, we can plug those into our formula. We have y2 minus y1 over x2. I did the wrong number there. That's why it's always good to label so you can see which numbers you should be plugging in. Our y1 is negative 2, and then our x2 is 13 minus 1. That gives us 36 over 12, and that simplifies to 3. So we have 3 degrees Fahrenheit per hour. That is our rate of change. Okay, let's look at the next example. This time we have a graph, and we see that the time, as time goes up, as time gets bigger, the distance that a person is riding their motorcycle gets further. So that makes sense, right? The more time someone spends riding their motorcycle, the further away they're going to get. So if we want to figure out how many seconds or how many meters they're going per second, we have to find the slope of this line. And to do that, we're going to find 2 points on that line. So it looks like it crosses right about here. And we have a point right about at the start, 0, 0. That's a good place to start too. So if we have our 2 points, 0, 0, and this is 20 and 400. You can find the slope using our formula, or if we have a graph, we can just count our rise over our run. So if we start at 0, 0 and we count up, we go 100, 200, 300, 400. So our rise is 400, and then our run is how many over. So let's see, and we have to be careful with our scale here. So this would be 4, 8, 12, 16, and 20. So we have 400 over 20. That simplifies to, we get 40 over 2, which is 20. So our speed here is 20 meters per second. That is our rate of change, or our slope of that line. Okay, let's look at number 4. We have another graph, so we can find 2 points and find our rise over our run. Now our first and our last point look like they land nicely on those intersections. So that is where I'm going to start counting my rise over my run. Now again, I'm going to be careful of my scale, so I'm starting at 60, and my next line goes up to 80. So that means I'm counting by 20s instead of 1s. So if I go up, I go 20, 40, 60. So my rise is 60. And my run, I'm going by 1, so I can count by 1s. 1, 2, 3, 4. So $60 for every day. So if I simplify that, 60 divided by 4 gives me 15. So that means I have $15 per day. That is my slope, or my rate of change. Okay, we have one more example down here to look at. This one says we have an airplane landing, and it starts at about, that looks like about 15,000 feet up here in the middle, 1,500 feet, and it's coming down, and we want to know what the rate of change is as that airplane is landing. So if we look at the 2 points it gives us here, this one is 60, 1,000, and we've got 180, 0. So that means it is on the ground. It is not high up above anymore. It is flat on the ground. So if we use our rise over run, we start here. Our rise is going down this time, and since we're going by 1,000s, this is going down a negative 1,000. Then we're going over to the right, and we're not going by 1s, we're going by 60s. So this is between 60 and 120, we have a 60, and then between this 120 and 180 is another 60. So that change is 120. Now if that is too difficult for you to count those differences, another way you can find that slope is using our formula. So if we have our 2 points here, x1, y1, and x2, y2, we can just use those numbers and plug them in. So we would have 0 minus 1,000, and 180 minus 60. And this is going to give us that same answer, which it should, negative 1,000 over 120. So whichever way is easier for you, that's the way I want you to do it. And then we can simplify that fraction. Negative 1,000 over 120 gives us negative 25 over 3. So this tells me that we're going down 25 feet. So this is my feet, and this is my seconds. So we're going down 25 feet every 3 seconds. That is my rate of change for this graph.